So in our previous session, we have learned the standard derivative of this form, that is limit sin x by x as x close to 0, value is 1. Now put the value as h tends to 0, we get minus 1 by x into x plus 0. X plus 0 is x into x becomes x square, so therefore minus 1 by x square. Now here, since we have sin h by 2 sin h by 2 as h tends to 0, this entire function value will become 1. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Department of Mathematics. Today in this session, we are going to learn about the derivatives of the function, and we will learn the derivatives of the function with the help of first principle of derivatives. So what do you mean by derivatives? So we have learned about the limit of a function. Suppose f is a real valued function and a is a point in its domain of the definition. The derivative of f at a is defined by limit of f of a plus h minus f of a divided by h. So if this is the derivative of a given function at the point a. So if f is a real valued function whose limit exists, and we are taking any point in the domain where f is defined, then the derivative of that function, that is also denoted in the form of f dash or sometimes dy by dx. So now that derivative is defined or is found using the following definition, that is limit f of a plus h minus f of a divided by h as x close to 0. This is possible only if the limit of the function exists, and hence derivative of the function f of x at point a is denoted by f dash of a. So if f of x is the function, then the derivative of the function is denoted by f dash of x. So that means we are deriving with respect to x. We are finding the derivative of a function with respect to x. So if the derivative is found at point a, then instead of f dash of x, we write it as f dash of a. So thus, the derivative of the function at a point a is given by f dash of a, whose definition is the same, that is limit f of a plus h minus f of a divided by h. So this is how we will get the derivative of the function, and this is how the derivative is defined. So let us take an example here. Find the derivative of 99x at x is equal to 100. So first we will write our function f of x is equal to 99x. Now I need to find out the derivative of this function. So that means I need to find out f dash of x. So f dash of x defined in such a way that limit h close to 0, f of a plus h minus f of a divided by h. So here the value of a is 100. So therefore, wherever you will find a, there you should substitute 100. So this becomes f of 100 plus h minus f of 100 whole divided by h. Now here you can see the defined function f of x is in the form of 99x. So whatever may be the value of x, it should take the value of 99x. So therefore this becomes 99 into 100 plus h. And here f of 100 becomes 99 into 100. So 99 into 100 whole divided by h. So here you need to write limit as h tends to 0, limit as h tends to 0 until you apply the limit for h. So now here again limit as h tends to 0. This can be written as 99 into 100 plus 99h minus 99 into 100 whole divided by h. You can see this is positive and negative with the same value, and hence it gets cancels. Now we have 99h by h. So limit h tends to 0, 99h by h. h get cancels. We are left with limit as h tends to 0, 99. So there is no other variable which has h to substitute h is equal to 0. So therefore 99 is a constant, and hence 99 will be the final value. Therefore the derivative of the function 99x is 99 at x is equal to 100. Next one, find the derivative of f of x is equal to sin x at x is equal to 0. So now we are finding the derivative of the function f of x sin x at x is equal to 0. So therefore, f dash of 0 can be written as limit as h tends to 0 f of a plus h, that is 0 plus h minus f of 0 whole divided by h. Now here this becomes limit as h tends to 0. So f of 0 plus h means it can be written as sine of 0 plus h minus f of 0 means sine 0 whole divided by h. Now apply the limit as h tends to 0. Sine 0 plus h is sine h minus sine 0 value is 0 whole divided by h. So we will get limit as h tends to 0 sine h by h. So in our previous session we have learned the standard derivative of this form, that is limit sine x by x as x close to 0 value is 1. So in the place of x we have h, but the definition is same and hence the value of this function is 1. So therefore the functional value or the derivative of the function sine x at x is equal to 0 takes the value 1. Next one, find the derivative at x is equal to 2 of the function f of x is equal to 3x. So we are taking f of x is equal to 3x at x is equal to 2. So therefore, f dash of 2 can be written as limit h tends to 0 f of 2 plus h minus f of 2 whole divided by h. Now f of 2 plus h can be written as 3 into 2 plus h and f of 2 can be written as 3 into 2 divided by h as limit x tends to 0. Just use the definition and the rest of the steps are very easy to simplify. So now limit h tends to 0, 3 2s are 6 plus 3h minus 6 whole divided by h. So limit as h tends to 0, 6 minus 6 cancels, 3h by h cancels. We get limit as h tends to 0 for 3. 3 is a constant and there is no variable to apply the limit. So therefore, the value is 3. So therefore, the derivative of the function f of x is equal to 3x is 3 at the point x is equal to 2. So until now, we have found the derivative of a function at the given point. Now if the point is also a variable, suppose we don't know the exact value of the point A, then also we can find the derivative with the help of first principle of derivative. So it is the same definition, but instead of A, we are taking x. So x may be any point in the given domain. So therefore, derivatives of a function f at any point x is defined by f dash of x limit f of x plus h minus f of x by h. Usually we would have taken it as a plus h, but a is the particular point. But for at any point, whatever may be the point, the derivative of the function can be defined as f of x plus h minus f of x divided by h, applying limit as h tends to 0. Now we can also define f dash of x in some other form, d by dx of f of x or dy by dx. Why? Because y is always expressed in functions of x. So therefore, f dash of x is nothing but derivative of y with respect to x. So we are deriving the function y with respect to x variable. So here y is dependent and x is independent. So therefore, we can also write dy by dx instead of f dash of x. Now find the derivative of the following function with the help of first principle. So whenever using the first principle, we do not have a particular point. We are deriving or we are finding the derivative of a function at any point. We can call it as x. So now we need to find out f dash of x. So f dash of x can be written as limit h tends to 0 f of x plus h minus f of x whole divided by h. So now limit h tends to 0, f of x plus h can be written as 10x plus h minus 10x. So whatever the value of x here, it should replaced h. So limit h tends to 0, 10x plus 10h minus 10x divided by h. 10x minus 10x cancels. We have 10h by h cancel. Now we can't apply the limit for a constant value. So therefore, we can remove the limit and directly write the value of this is 10. So therefore, the derivative of 10x is 10. So for any point, if you take x value as 2, then also it is 10. If you take the x value of root 7, then also it is 10. So whatever may be the point x, the derivative of 10x will be 10. The second one is, we are taking the function f of x is equal to x square. So I am taking the definition of the derivative here, that is f dash of x limit h tends to 0, f of x plus h minus f of x divided by h. Now if I write f of x plus h, then it should take the value of x plus h whole square. So write x plus h whole square. F of x is nothing but x square, write it divided by h. Expand this, a square plus b square plus 2ab form. So x square plus 2hx plus x square. We can cancel x square here and we can take h as a common factor in these two terms. So taking h as a common factor, we get 2x plus h. H and h get cancelled. Now apply the limit here. When you take h value as 0, if you put h is equal to 0 here, then the remaining value is 2x and hence it is 2x. So therefore, the derivative of the function x square is 2x. So similarly, we can find f of x is equal to 1 by x here. So let us take the derivative definition. F dash of x is limit as h tends to 0, f of x plus h minus f of x whole divided by h. So this becomes limit as h tends to 0, 1 divided by x plus h minus 1 by x whole divided by h. Again limit as x tends to 0. So taking this fraction, we get x minus h divided by x into x plus h whole divided by h. We can cancel x here. We can also cancel h. So we are left with limit h tends to 0 minus 1 divided by x into x plus h. Now put the value as h tends to 0, we get minus 1 by x into x plus 0. X plus 0 is x, x into x becomes x square, so therefore minus 1 by x square. So therefore the derivative of 1 by x is minus 1 by x square. Now this is how we have proved with the help of first principle derivative. Next one, find the derivative of the following, use the first principle. So let us take the definition here. F dash of x is equal to limit as h tends to 0, f of x plus h minus f of x whole divided by h. So now limit as h tends to 0, this can be taken as x plus h whole power n minus x power n divided by h. Now here in the denominator, what I'll do, I'll add x and I'll subtract x. I'll separate this. We have learned the standard result that limit as x close to a, x to the power n minus a to the power n divided by x minus a can be written as n into a to the power n minus 1. Now this is of the same form. Here you can see x value is x plus h. So if x value is x plus h, obviously h tends to 0 and hence x close to a changes to x tends to 0. And now in the place of a, we have x. So therefore, if I change or if I apply the standard result, we will get n into, instead of a we have x. So it is x to the power n minus 1. So this is the result. So therefore, for f of x is equal to x to the power n, we get n into x to the power n minus 1. We can also check this result. we have found the derivative of x square, that is we got f dash of x as 2x. So use the standard result. So x square means this can also be written as 2 into x to the power 2 minus 1, which becomes 2x. So instead of finding with respect to first principle, just by applying the standard result also we can find the derivative as 2x. And here we got 1 by x as minus 1 by x square. So let us use the concept of x power n. If f of x is equal to x power n, then f dash of x, we got it as n into x to the power n minus 1. Now here we have 1 by x. So f of x is equal to 1 by x means I can write this as x to the power minus 1. So therefore f dash of x becomes minus 1 into x to the power minus 1 minus 1, which is minus 1 into x to the power minus 2, which can be written as minus 1 by x square. See, these are equivalent. So this is with the help of first principle derivative, and this is using the standard formula to find out the derivative. So for any power, for any n of x, the derivative can be written as n into x to the power n minus 1. We have done with the x square also, we got it as 2x. If you use the x power n, then also we'll get it as 2x. For f of x 1 by x also we got the same answer. And hence this one can be taken as a standard derivative. Next one, we have f of x is equal to sin x. So previously we have found the derivative of sin x at x is equal to 0 as 1. How? So here for f of x is equal to sin x, the derivative you got it as cos x. So therefore, which means the derivative of sine function is cos x. So at x is equal to 0, obviously cos 0 will become 1. And hence we got the derivative of sin x at x is equal to 0 as 1. Now using first principle derivative, we have found the derivative of sine function as cos x. So first, take the definition of the first principle of derivative, that is limit fx plus h minus f of x by h as x close to 0. Now f of x in the form of sin x, so therefore f of x plus h should take the value of sin x plus h minus sin x. Now here you can use the formula of sin a minus sin b or sin x minus sin y, which can be written as 2 cos x plus h by 2. So, or you can add this 2 cos x plus h plus x by 2 and x plus h minus x by 2. So, using that result, we get here 2 cos x plus h by 2 into sin h by 2. So, this is how using the transformation formula, that is sin x minus sin y can be written as 2 cos x plus y by 2 sin x minus y by 2. Now since x value is x plus h, y value is x here, x plus x becomes 2x plus h. So 2x by 2 becomes x, h by 2 remains the same. And here x minus y, x plus h minus x means x cancels, we are left with h by 2. Now again here we have 2. I'll shift 2 to the denominator, then h becomes h by 2. Why? Because this function will be in the standard form of sin x by x as x close to 0. Now here since we have sin h by 2 sin h by 2 as h tends to 0, this entire function value will become 1. Apply the limit for the remaining function, cos x, put h as 0, then 0 by 2 becomes 0. Cos x plus 0 becomes cos x into 1 cos x, and hence the derivative of sine function is cos x. Similarly, we have found the derivative of cos x function also. Take the definition of the first principle of derivative. Use the transformation formula of cos x minus cos y. We know that cos x minus cos y can be written as minus 2 sin x plus y by 2 and sin x minus y by 2. Now taking x as x plus h and y as x, this can be reduced in this form, that is minus 2 sin x plus h by 2 sin h by 2 by h. Again, shift 2 to the denominator such that sin h by 2 divided by h by 2 will form. Because if you apply the limit for this function, then its standard value becomes 1. Now apply h tends to 0 for the remaining function. H takes the value 0. We have minus sin x plus 0 into 1. We get minus sin x. Hence, the derivative of cos x is minus sin x. Next, we have the function tan x. Apply the standard derivative. Apply the definition of the first principle of derivative. Convert the function in the form of x plus h and x. So, fx plus h means tan x plus h. And f of x means tan. Now, tan can be written as sin by cos, sin by cos. Cross multiply sin x plus h into cos x minus sin x into cos x plus h whole divided by cos x plus h cos x. So, 1 by h keep as it is. Now, here we have sin a cos b minus cos a sin b form. So, which can be written as sin a minus b. So, therefore, this can be written as sin a minus b. Plus x minus x cancels here. We are left with sin h. We also have h here. So, this can be written separately because it takes the standard form. And the remaining terms can be applied separately. So, limit x tends to 0, 1 by cos x plus 0 cos x. Now, if you apply the limit here, this entire value is 1. Here you get 1 by cos x, 1 by cos x, 2 cos x in the denominator which become cos square x. And 1 by cos x is secant x. So, cos square becomes secant square. Therefore, the derivative of tan x is secant square function. So, thus with the help of the first principle of derivative definition, we can find the derivative of any function at the given point or at any point x. So, here we have some of the standard results which we have done, that is the standard derivatives of certain function. For any constant, the derivative of the function is 0. It may be 1, pi, e power 2, 1 by e. So, for any constant, its value is always equal to 0. Now, the derivative of x power n, we can write it in the form of n into x to the power n minus 1. So, derivative of sin x, we got it as cos x. Derivative of cos x is minus sin x. Derivative of tan x is secant square x. Similarly, with the help of first principle of derivative, we have all the standard derivative for the given function. So, derivative of secant x can be taken as secant x into tan x. Derivative of cosecant x can be taken as minus cosecant x into cot x. Derivative of cot x can be taken as minus cosecant square x. So, thus all these standard forms you have to learn it. So, basically it helps while solving the derivatives of the composite functions. Next we have the Leibniz rule for differentiation. So, what does this Leibniz rule says? So, when you are applying or finding the derivative of two functions in the form of sum and difference, you can find them separately. So, derivative of one function plus another function. Suppose if you have a function in the form of sin x plus cos x as f of x, then the derivative can be separately found. So, what is the derivative of sin x? Cos x. And what is the derivative of cos x? Minus sin x. Like this. So, you can find the derivative separately whenever it is in the form of sum or difference. Next, if a function is with constant, then you need to remove the constant and find the derivative only for the function. For example, if you have a function f of x is equal to 3x square, you need to find out the derivative f dash of x. Since 3 is a constant, write 3 separately. Now, derivative of x square is 2 into x to the power 2 minus 1 using the standard result n into x to the power n minus 1 for x power n. So, if your function is x power n, then its derivative is n into x to the power n minus 1. So, this becomes 3 into 2x, which becomes 6x. So, if you have a constant along with the function, keep the constant outside and derive only the function. Next, we have a product rule. This is called as product rule. When you are deriving, this dash represents the derivative of the function. So, when you are deriving the function in the product form, then you should apply this rule. So keep the first function as it is, derive the second, plus keep the second function as it is, derive the first function. So let me take an example. I am deriving or I am finding for sin x into cos x. So then f dash of this function becomes, see, u should be same. So sin x into derivative of cos x. What is derivative of cos x? Minus sin x. Plus, keep v same. So second function cos x into, what is derivative of u dash? U dash means derivative of sine. Derivative of sine is cos. So we'll get the answer as cos square x minus sine square x. So this is the value. So this is the product rule. First function into derivative of second plus second function into derivative of the first. So the last one, we have the quotient rule. So whenever any function is in the form of u by v, that is u by v form, that's in the fraction form, then you can write this as vu dash minus uv dash divided by v square. That means keep second function as it is, derive first, minus first, derive second, divided by v square, that is denominator the whole square. For instance, derivative of tan is secant square x. But tan can be written in the form of sine by cos. So now if I apply the quotient rule here, quotient rule says vu dash minus uv dash divided by v square. Here this is u and this is v. So applying the standard result here, v cos x into u dash. U dash means derivative. U is sin x. U dash means derivative of sin x. So derivative of sin x is cos x. Minus, next we have u, that is sin x. V dash. V dash means derivative of cos x. So derivative of cos x is sin x. Divided by v square, cos square x. So here we got cos x into cos x, cos square x, minus into minus plus sin square x, whole divided by cos square x. We know that sin square plus cos square is 1. So we get 1 by cos square. 1 by cos is secant. So 1 by cos square is secant square x. See, we got the same value. Tan x is secant square x. Sin by cos is also tan. But here tan is in the quotient form of sin by cos. So if we apply the quotient rule also, we'll get the same derivative. So this is how it helps, that Leibniz rule helps in simplifying the derivatives of composite functions. That is one or more function in the form of a sum, difference, product or quotient. So remember all the standard derivatives of the function, also the Leibniz rule. So we'll take few problems and find the derivatives of them in our next session. Until then, keep watching, keep learning and keep exploring. Thank you.